my dear learners, I am Dr. Pawan Kumar Shukla, professor at RKGIT Ghaziabad in the Department of Electronics and Communication Engineering. I was discussing some of the very major important topics in the antenna theory, and in my last few lectures I was discussing the details of antenna array system, and some of the antennas are very much important to nowadays. Basically, the pattern of the antennas have been changed, the scenario of communication has also been changed, the frequency range has been increased very much. When we were talking about the radio frequencies of kilohertz and megahertz only, nowadays we are using the frequencies in the terms of gigahertz and more than that also. So, the pattern of antennas, pattern of antenna array system has completely changed nowadays. So, today I will discuss a very important kind of antenna which is very much popular in the recent communication systems, always used in the telecommunication system where the frequency range is very high, and to adopt the receiving frequency, a very small or very thin antenna system is designed, which is known as the microstrip antenna. So, my today's lecture is based on that particular antenna which is very popular nowadays in the recent days communication systems. Let us start. What is microstrip or patch antenna? Microstrip antenna is also known as the patch antenna because it is in the form of a patch. The shape and the size of this microstrip antenna is very small, and that is why it is shown like a patch itself. Microstrip patch antenna consists of a radiating patch on one side of a dielectric substrate which has a ground plane on the other side as shown in the next figure. Simply a microstrip antenna is that kind of device or that kind of very specific component which is used nowadays in very compact size equipments or components or devices of communication, embedded system or any other electronic device, where we have to use a very small sized antenna which can work at a very high frequency. So, this is the basic utility and application of a microstrip antenna. The patch is generally made of conducting material such as copper or gold and can take any possible shape. The radiating patch and the feed lines are usually photo etched on the dielectric substrate. Obviously, when the size of these antennas is so small that we have to use a very special kind of material, or you can say it is very much similar to the fabrication of an integrated circuit, where we use the substrate or the wafer or the dielectric material or any other kind of material based. The properties of the materials are responsible for the functioning and operation of the antenna system. So, in order to simplify the analysis and performance prediction, the patch is generally square, rectangular, circular, triangular, elliptical or some other common shape as shown in the figure. That was theory, and this is the practical aspects of the microstrip antenna. How we can design a microstrip antenna for the practical applications. In the upper diagram, we have shown a very conventional type of microstrip antenna, in which it is given that this is a basic substrate and 1 and 2, simply this is the patch. This is the patch, and which is known as the microstrip patch. This is the dielectric substrate, it is the ground plane, and the complete material which is form here, here and here, this is the substrate and this is the patch. So, simply the different structures, the different shape of the microstrip patch are given here. What are the different dimensions of the patch antenna? For a rectangular patch, the dimensions are very important, or every kind of microstrip patch antenna where the dimensions are very less, because we have to install such microstrip antenna very small device. So, obviously, we have to design the microstrip antenna in the dimensions which are in the millimeter, or these are in the form of centimeters. So, in the dimensions of centimeters and millimeter antennas, obviously, when we talk about the lambda naught is that frequency, is that wavelength which is corresponding to the frequency of operation, and when we use the frequency of operation in the range of several hundred megahertz or several hundred gigahertz, this is already in the terms of millimeter or centimeter. So, the dielectric constant of the substrate epsilon r is typically in the range of 2.2 to 12, means the dielectric constant lies between the 2.2 and 12 for the microstrip antenna for which the substrate material is used. Microstrip patch antenna radiate primarily because of the fringing fields between the patch edge and the ground plane. For good antenna performance, a thick dielectric substrate having a low dielectric constant is desirable, since it provides better efficiency and larger bandwidth for the better radiation. These are the advantages of the patch antenna. How the patch antennas works, because the area and the dimensions of the patch antennas are very wide and very sensitive. So, the whole designing of the microstrip antenna is based on its dimensions. The calculations of the different dimensions like width, height, length, all these parameters are based on the calculations. Some of the calculations are based on the antenna theory, some of the calculations are based on the communication system, and some of the calculations are based on the different high level software systems which are used for the purpose of simulation in the antenna design. So, advantages can be given like light weight and low volume. Obviously, these are having the least volume, least space and least structure when it occupies the least space. Low profile planar configuration, easily made and conformal to the host surface. These are having very low fabrication cost, and it supports both linear as well as circular polarization. It is a very important aspect, because circular polarization is also needed in some of the very specific applications when an antenna is required at very high frequencies. They can be easily integrated with microwave integrated circuits, and they are capable of dual and triple frequency operations as well. Mechanically robust when mounted on the rigid surfaces. These are some of the advantages of patch antenna, although nowadays they are very popular and they are very much useful. Most of the applications in communication systems, they utilize only the microstrip antennas. Some of the disadvantages are also with the microstrip antennas, like they are having narrow bandwidth, low efficiency, low gain. They are extraneous radiation from feeds and junctions, poor end fire radiator except tapered slot antennas. They are having low power handling capacity. They are used for high performance aircraft, spacecraft, satellite and missile applications where size, weight, cost, performance, installation and aerodynamic profile are constraints. Other areas where microstrip antennas are widely used, they are GPS, telemetry, radars, meter. Basically, there are many other applications apart from the basic telecommunication system or other engineering services. So, simply the technology nowadays which is utilizing the very high frequency applications are using the microstrip antennas for the communication purposes. It is a very important concept in the case of microstrip antenna, because the feeding is very important and the pattern, the methods for which a microstrip antenna is fed with the different kind of excitation, it is given like this is the type 1 excitation or type 1 feed system. It is known as microstrip line feed. In this type of feed technique, a conducting strip is connected directly to the edge of the microstrip patch as shown in the figure, this one. This is the diagram which is shown for the first kind of feed system. Firstly, we have to understand what is the feed system, why we use a very unique kind of feed system in the microstrip patch antennas, because they are very they are having very less space, they are very compact, they are very small in size. So, the current conductivity within these antennas is given by the feed system, by the excitation, and this excitation is given here. You can see that this particular form is known as the feed system from where they get the current, and this is the patch, and through this patch this is the feeds. However, as the thickness of the dielectric substrate increase, surface waves and spurious feed radiation also increases, which hampers the bandwidth of the antenna, and this kind of feeding technique results in undesirable cross polarization effect. This is the drawback of this kind of feeding technique. Second kind of feeding can be done in the microstrip antennas through coaxial feed. The coaxial feed or probe feed, it is also known as the probe feed, is one of the most common technique used for feeding microstrip patch antenna. From the given figure, you can see that this is the circular microstrip patch in the form of microstrip antenna. This is the dielectric substrate. This is the coaxial connector through which the current is going to be feeded in the microstrip patch antenna, and this is the structure and this is the pattern through which the feeding is done or coaxial feed is going to be worked in the microstrip antenna. The main advantage of this kind of feed is that it can be placed at any desired position inside the patch in order to obtain impedance matching, and this feed method is easy to fabricate and has low spurious radiation effects. The major disadvantage is that it provides narrow bandwidth and difficult to model, since a hole has to be drilled into the substrate, and the increased probe length makes the input impedance more inductive, leading to the matching problems. By using a thick dielectric substrate to improve the bandwidth, the microstrip line feed and the coaxial feed suffer from numerous disadvantages such as spurious feed, radiation and the matching problem. So, this kind of feed system is having advantages and disadvantages both. We improve the performance and we use aperture coupled feed. Some of the disadvantages have been eliminated in this kind of feed system, in which The radiating microstrip patch element is etched on the top of the antenna substrate and microstrip feed line is etched on the bottom of the feed substrate to obtain aperture coupling. The thickness and dielectric constants of these two substrates may thus be chosen independently to optimize the distinct electrical functions of radiation and circuitry. The coupling aperture is centered under the patch. You can see here how this function performs. This is the complete patch, this is the slot, and particularly the feeding is done with this light, you can see here this dotted line. And when this kind of feeding is done, this type of feeding technique can give very high bandwidth of about 21% greater than the conventional frequency of operation. Also the effect of spurious radiation is very less as compared to the other feed techniques. The major disadvantage in this technique is it is difficult to fabricate due to multiple layers, which also increases the antenna's thickness. The last type of feeding system is known as the proximity coupled feed. As its diagram shows that the feeding is done like this, and this feeding is done with the two different kind of materials, in which the patch is performed on a different kind of dielectric constant dielectric material, and the substrate is based on the different kind of dielectric material. And this feeding, this kind of feed technique is also called as the electromagnetic coupling scheme, as shown in the figure. The two dielectric substrates are used such that the feed line is between the two substrates and the radiating patch is on the top of the upper substrate. Basically, advantages and disadvantages of the proximity feed system can be summarized like: it eliminates spurious feed radiation and provides very high bandwidth of about 13%. Due to increase in the electrical thickness of the microstrip patch antenna, it also provides the choices between two different dielectric media, one for the patch and one for the feed line, to optimize the individual performances. It is difficult to fabricate, obviously, because of the two dielectric layers that need proper alignment, and also there is an increase in the overall thickness of the antenna system. The comparison can be done among all these four type of feed system, like microstrip line feed, coaxial feed, aperture coupled feed and proximity coupled feed. And all these type of feed system can be compared with the characteristics like spurious feed radiation, reliability, ease of fabrication, impedance matching and bandwidth. So, simply we can see here that some of the feeding system are having very important aspects and very important advantages over the applications of microstrip antennas, and we use all these properties to form, to design, to fabricate such kind of microstrip antenna, because nowadays it is very popular and the different softwares are also used to design such antennas. Obviously, the proximity type, or simply we can say that some of the microstrip antennas can be at very high frequencies. Some of the microstrip antennas can be identified or can be designed theoretically only, but they cannot take the practical size as they are having very less dimensions. So, it was all about the microstrip antenna, which is a very unique feature, and also I can say that microstrip antenna is a very specific kind of topic which can be understand, which can be think about the future of the antenna theory. because as we are going and as the communication system is moving towards high frequency applications, then obviously we have to find out some of the solutions, some of the antennas which are very much useful at very high frequency. Obviously, at very high frequencies the wavelength is minimized, and at very low dimensional wavelengths we can design a very short, very small, very narrow and very compact sized antennas, and these compact sized antennas can be configured only through the patches, and these patches are very much parameters sensitive, dimensions wise sensitive, and they are having very calculative decisions as far as their design is concerned. So, my today's lecture was based on the microstrip antennas, but the theory, the analysis, the study of these microstrip antennas is a very special kind of theory, very special kind of study, and we all have to make the sense to understand the microstrip antenna in a very individual way. In this particular subject, antenna and wave propagation, microstrip antenna is having only an introductory idea, but the field of microstrip antenna is very vast, very wide, and the future of antenna is based on the microstrip antenna. So, thank you very much for watching this video. In my next lectures, I will discuss some more important aspects of the antenna and wave propagation. Thank you very much.